What if SpaceX has already found a way to launch Starship to the moon without needing to refuel in orbit? NASA's biggest concern right now isn't the rocket's size or even its landing legs, it's refueling. The whole lunar mission plan depends on an unproven process that's never been done before. But what if Elon Musk's engineers are already working on something far more powerful? A Starship powered by nuclear energy. Sounds unbelievable? Maybe not, because the technology exists, and it might just be the brilliant solution SpaceX needs to make lunar missions faster, simpler, and far more reliable. Let's start with NASA's biggest worry. The agency has awarded SpaceX a multi-billion-dollar contract to build the Human Landing System, or HLS, a version of Starship that will carry astronauts from lunar orbit down to the moon's surface. But here's the catch. The HLS Starship can't carry enough fuel to launch from Earth, reach orbit, and then land on the moon. To solve this, SpaceX plans to launch multiple Starship tankers, possibly 10 to 12 separate launches, each carrying propellant to an orbital depot. Once full, this depot would transfer fuel to the Lunar Starship, which would then begin its journey to the moon. Sounds good in theory, but in practice, it's one of the most complex space operations ever attempted. Every single tanker must launch successfully. Every docking must align perfectly. Every cryogenic transfer must happen without leaks or boil-off losses. NASA's entire schedule depends on it. Any delay in one step could derail the whole timeline. NASA has seen what happens when even one launch slips. It can push a mission back by months, sometimes years. Now let's talk about why orbital refueling is such a big deal. Refueling cars is simple, but in space, you're dealing with super-cooled liquids, methane at minus 161 degrees Celsius and oxygen at minus 183. These propellants naturally boil away in sunlight. To keep them stable, Starship's tanks must stay extremely cold, shielded, and precisely managed, all while orbiting Earth at 28,000 kilometers per hour. And that's not all. The depot, a giant floating gas station, can only survive in orbit for a limited time. Hardware degrades, ice forms, micrometeorites pose constant threats. You've got a narrow window, maybe a few weeks at best, to get all your tankers up, refuel the depot, and then send the crewed Starship to the moon. That's a lot of moving parts, and for NASA, every moving part is another point of failure, which raises the question, what if SpaceX could simply skip refueling altogether? That's where this bold idea comes in. Imagine a Starship that doesn't rely on chemical fuel alone, one that's powered by a nuclear thermal propulsion system. It's not science fiction. NASA actually tested this concept back in the 1960s under a program called NERVA, the Nuclear Engine for Vehicle Application. Those tests achieved specific impulses over 900 seconds, double what the best chemical rockets can do today. That means a nuclear-powered engine can produce the same thrust while using half the fuel. And less fuel means less mass, and possibly no need for orbital refueling at all for lunar missions. Here's how it could work. A conventional super heavy booster still launches Starship from Earth, just like today. But once it's safely in orbit, the nuclear reactor, located deep inside the spacecraft, activates. Instead of burning methane and oxygen, it heats hydrogen propellant to extreme temperatures, ejecting it through a nozzle at tremendous velocity. The result? Twice the efficiency, longer burn times, and the ability to reach the moon in just a few days, instead of the current multi-phase refueling-heavy plan. A nuclear-powered Starship could take off using chemical engines, switch to nuclear propulsion once in orbit, and then head straight to the moon. No refueling required. For the crew, that means fewer risks. For NASA, it means simpler timelines. And for SpaceX, it means massive cost savings. A typical Starship tanker launch costs around $90 to $100 million. Up to 12 launches might be needed for one lunar mission. That's close to $1 billion in refueling costs. Compare that to one nuclear-equipped Starship that can perform the same mission with a single launch. The economics start to look very tempting. Elon Musk has hinted before that nuclear propulsion could make sense for deep space. And NASA's Draco program, short for Demonstration Rocket for Agile Cislunar Operations, is already testing a small-scale nuclear rocket for launch in 2027. If Draco succeeds, it could pave the way for larger, crew-rated designs, potentially even something the size of Starship. Of course, there's a reason why we're not already flying nuclear rockets: safety. If a nuclear-powered Starship were to explode on the launch pad before reaching orbit, the radioactive contamination could be catastrophic. That's why these engines would never ignite inside Earth's atmosphere. Instead, the reactor remains cold and inert during launch. Only once in orbit, after all safety checks, would the core go live. Modern reactor designs use low-enriched uranium, reducing meltdown risk, and multiple containment layers to prevent radiation escape even in extreme scenarios. Still, convincing the public and regulators is no small task. One launch failure could set nuclear propulsion back decades. So, if SpaceX did build a nuclear Starship, what would it actually mean? For one, faster, simpler lunar missions. Instead of relying on a dozen support launches, a single Starship could make the trip in days. For another, sustained lunar operations. Nuclear systems could generate continuous power for lunar bases, enough to run life support, communications, and fuel plants for months at a time. And looking even further, Mars. A nuclear Starship could cut travel time to Mars from 6 months to just 90 days. Less exposure to radiation, fewer life support demands, and more mission flexibility. That's a game changer. It's not just about efficiency, it's about redefining what's possible in human spaceflight. So, will SpaceX actually build a nuclear-powered Starship? For now, it's still speculative, but there are hints. Engineers at SpaceX have explored cryogenic management, high-temperature alloys, and long-duration propulsion systems, all of which overlap with nuclear propulsion technology. NASA and DARPA's investments in Draco and other nuclear propulsion initiatives show that this isn't fantasy, it's a future under construction. If SpaceX sees a way to align with those programs, we could see prototypes emerge in the early 2030s. And if that happens, the era of orbital refueling may come to a close sooner than anyone expected. Whether it's chemical, electric, or nuclear, one thing's certain: SpaceX isn't standing still. Every Starship test brings us closer to the day humans walk on the moon again. But the real revolution might not be about landing. It might be about how we get there. A nuclear Starship could make lunar travel as routine as crossing the Atlantic once was for ships, and from there, the solar system becomes our ocean. The question now is, will the first humans to set foot on Mars get there aboard a nuclear-powered Starship? We might find out sooner than we think. If you found this idea as thrilling as the possibilities it opens, make sure to hit subscribe and turn on notifications, because the future of spaceflight is unfolding faster than ever, and we'll be right here breaking down every step of SpaceX's journey to the Moon, Mars, and beyond.